All right, here we are for another lesson. We got, let's go ahead and see what we got. So, write expressions in radical forms and use the square root property to solve quadratic functions. So, let's see what we need to know about this. Let's see, reviewing radical expressions. So, a radical is an expression with a square root, cube root, or something. It looks like this. All right, and then sometimes they'll have a little number here that we call the index. So that's why it says cube root, because that would be to the third root. And to get you started, let's go ahead and list out the first 20 perfect square numbers. So perfect square numbers are the ones that you would multiply the same number. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 16 is 4 squared, and 5 squared is 25. And then so on, all the way up to 20 squared, which is 400. And this list will be kind of useful because it'll help you recognize when a perfect square number shows up. And you know, if you see it, just look at the place of the place in the line that it is. So if it says 225, you can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So since this is the 15th one in the list, then you would know it's 15 squared. So this is also kind of helpful because I know not everyone will have a table, or if you have a calculator, you could probably just keep trying numbers until you find out which number squared gives you that number. So if you're simplifying radicals, there's a couple of things that can happen. So if we put a number in here, if the number is a perfect square, so if it is one of these, again, you can just count down. So if it was 361, we know that it's the 19th number in the order. So that would be the square root of 361 would be 19. If it is not a square number, and this is where you might have to do some work, break the radical down using the largest perfect square. So look for one of these numbers, factor it down. So you might have to make a factor tree. So that means to break the number into other numbers. So like, well, it'll make more sense once we get started in it. But you're trying to get square numbers out of it. And if there are any numbers that are not square numbers, we're going to have those as leftovers. So they're going to stay in the radical. All right, and for both cases, if there is a coefficient outside the radical, multiply this with any number that you take out. So I oftentimes describe this as like a roller coaster ride. So if you remember the carnival, sometimes they don't let you use sometimes they don't let you ride certain rides by yourself. So like if I had a sign like a 2 here, I'm gonna go with 2, even though normally when you don't see them, it's always a 2. And I'm gonna use a simple one, I'm just gonna use 4. So this sign here says you need 2 people to get on this ride. So what you need to do is you need to have 2 of them, because again, carnival rides oftentimes don't want to send empty seats out because it's just a waste of time and everyone's gonna have to wait in line longer. So we need to, well, in this case, this is like a group of people and we're gonna break it down. So 4 is made from 2 times 2. Now I have 2 of those numbers, and when they come out, so when they're out of the radical, that's gonna, well, actually, hold on. When we take it out of the radical, that means there is gonna be nothing left inside. And when there's nothing left in the radical, we don't really need it at all anymore. So actually, well, the root 0 is 1. So then that would become 2 times 1, which we know by identity property that it just means that it's just going to be the same number. 2 times 1 is still going to be 2. So that's why we have 2. And we just don't need this part here. And that's one way of thinking about it. So for this one, I'm going to go ahead and follow the what it says here. And there's a couple of different ways you can do this, but just because this is the way the packet here says to do it, that's the way we're going to do it. So let's start with the first set of exercises. And I think there's actually going to be, I think 12 of these. So write each expression below in simplest radical form. Okay, so radicals. We have the square root of 49. And some calculators can do it. Let me check my good old, not that very good dollar store calculator. So if I take 49 and I push square root, I do get 7. Weird. Okay. Now for number 2, I have, let's see, square root of 225. So 225, and I think I don't know if that was the exact example that I did earlier. Quite a coincidence if it was, because I didn't look at this thing ahead of time. Usually I look at the packet beforehand, but today I didn't. All right, so in this case here, 225 is equal to 15 times 15. Or again, we looked at the list and we saw that it is a perfect square number, and any number that is a perfect square number is going to be simplified to that number's root. But again, just for help on understanding it later, it might make a little bit more sense to think of it as pulling things out of a line, right? So in this line, we need 2 people to get on this ride. All right, so let's go ahead and do this one. So we think of 2 numbers. So now moving on to number 3, I'm thinking of 2 numbers that will multiply to, hold on. What the heck is going on with my mouse? Having a little bit of issues here. All right, hold on, I'm gonna pause. All right, so think of 2 numbers that multiply to 144, which again, if you have your list of perfect square numbers, we can see that 144 is a square number. And we know that it's the 12th number in the list in the order. So I'm gonna have 12 times 12. And again, this is just for when we get into simplifying non-perfect square numbers, it helps a little bit to think of it this way here. So I have 2 of them, and remember, if there is no index, meaning there is no number here, it's always going to be square root, okay? There is no such thing as a 1 root, because a 1 root would just be a regular number. So anyway, now there's 2 of them, but if you remember what the thing said, so it said in both cases, if there is a coefficient outside the radical, multiply this by any number you take out. So in this case, we're going to take out 12. So the radical is still kind of here. It's the square root of 0, which is just 1, and 1 times anything is nothing, so we're just going to ignore that. Or I'm sorry, is that same number. Getting my own properties confused. So now that we took out 12, we're going to multiply it by the number that's already outside. So in this case, we would have 24. So 24 is going to be our answer for this one. All right, so let's go ahead and move on to some exercises that are a little bit more difficult. If you have a fraction inside of the radical, one thing that can kind of help is to break each of these down into their own set. So kind of like distributive property, they both get one. They both get one of the radicals. So in this case here, I have the square root of 4, which we know the square root of 4, and that should be something we might know off the top of our heads. And here we also have the square root of 9, which is another one that we should also know right off the top of our heads. Some of these larger numbers, you know, they might be difficult to remember. That's why we listed them out to begin with. But most of the really small numbers, you know, like up to maybe like 64 or 81, or mostly anything less than 100, we would generally know what it is. All right, so let's go ahead and move on to the next one. And we have another radical split, or another radical with a fraction inside. So we're going to split it so that we have the square root of our top number and the square root of our bottom number. So the square root of the top number in this case is going to be 1, and the square root of the bottom number is going to be 9. So you can take the square root of 1, it's just going to stay 1. And if we take the square root of 81, we get 9. So in this case, I get 1 over 9, or 1/9 as our answer. And here we go, we got another one. So square root of 36 and square root of 121. So square root of 36, I'm guessing most people would know that would be 6 because 6 times 6 is 36. 121 is going to be a little bit more difficult. Now I know this one, but again, you can look at the list and see what it is, but it would be the square root of 11. I'm sorry, the square root of 121 is 11. Woo, just having an off day today. Close enough. Let me just go ahead and close that box. And there we go, 6 over 11. So far, nothing really that complicated. Just remember that if you have a fraction inside of your radical, then you would break it into 2 separate radicals. Sometimes you might not be able to take care of one, but I don't know. Like I said, I haven't looked over the packet today, so sometimes you might have one that cannot be simplified. But I don't know. I don't think they would do that because that would be a little bit of an extra work, and that would be something called rationalize the denominator, which again may or may not be useful today. So let's go ahead and keep going. So here we have a non-square number because, well, we know that 11 squared is 121, and 12 squared is 144. And since 112 is between 100 and, well, it's actually not, I thought it was between those two, but it's actually less than. So it's actually somewhere between 10 squared and 11 squared, which we know 10 squared is 100 and 11 squared is 121. And this does not, it's directly in between those, so it's not a square number. So being a square, not a square number, we're going to have to follow what it told us to do, and that is to break it down into some numbers that we can do. So there's a couple of different ways, and usually what I like to do is I like to break it all the way down. All right, breaking it all the way down is probably the easiest way to break it down. So any even number can be divided by 2. So 112 divided by 2. So we're going to end up with 56. And then 56, and if you follow the directions on the packet, it says to break it into square numbers. So in this case, I'm going to break down 52 into 2 again. So I get 2 and 28. And again, this is probably the easiest way in my opinion. So I get 2 and 14 is 2 and 7. So I broke down the number all the way down. And there is kind of a downside on this, and that is you need to do a lot of writing. So looking at the bottom of all the numbers, the numbers at the bottom of all of the factor tree, all of them, so it's 2, 2, 2, 2, so there's 4 2s, and then 1 7. And again, like the carnival ride in, example that I gave you earlier, we're looking for groups. Since I have 2 pairs of 2, we can take them out. And one of the problems with this is that sometimes you have to take, okay, so in this case, we're going to take 2 numbers out. I'm going to take one group of 2s and another group of 2s. So it can be a little bit confusing because when you take numbers out, remember, if there's any numbers that are already out, we have to multiply anything that comes out. So if we take a 2 out and we take another 2 out, we're going to have to multiply those 2 numbers together. So we end up with 4 root 7 in this case. And again, it's easy to break it down, but it can get confusing. So we're going to try using the other method that it told us to use in the packet. So just for the sake of this now, I'm going to go ahead and go back to the way the packet told us to do this. So in the packet, it tells us to break down these numbers using the largest square numbers that we can think of. So sometimes we might have to go back and try again. So in this case here, it's not an even number, so we can't divide it by 2. We could try 245 divided by 3, and that does not work. So 3 would not work. It'd be like 81.6666, which we don't want. We only want integers and whole numbers if we can. All right, so we can divide it by 5. So 245 divided by 5 would be 5 and 49. Now in this case we lucked out because 49 is a square number. So if you think of the number back in radical form, it would be 5 times 49. One thing you can do, kind of like we did with the fractions, is that we can break it down into each part. So we had a fraction, which remember, if you remember, a fraction is a division. So we break it down into 2 divisions. You can also do the same thing with multiplication. I'm going to break it down into 2 multiplications. So I have square root of 5 times the square root of 49, which we can take the square root of 49, that would be 7, times the remainder. Well, in this case, we don't say remainder because remainder already means something. The leftover is what they called it. So 5 is the leftover, so we cannot take that out. And it just stays in there. So there's nothing we can do, nothing else. So again, square root of 5, nothing much we can do. So that's it. Let's go ahead and do this one here. Now this one has a number on the outside. So anything that comes out will have to be multiplied by 5. So let's think of 2 numbers that can multiply to make 72. Actually, let me keep this the same. So think of 2 numbers. Now, if I told you to think of 2 numbers, you would probably think of like 9 and 8. 9 and 8. Which 9 is a square number, but 8 is not. So we could have square root of 9 and square root of 8. But if you remember the directions, it says the largest square number that you can take out. So let's see if we can find something that is larger. So let's go with, again, 72, and we're going to break that into 3. 72 divided by 3 is going to be 24. So this is not going to work out. We could also try 72 divided by 2, and that would be 2 times 36. And like I said, you might have to try a couple of times to get the largest square number, but I think this is probably one of the methods that is least confusing. So even though you do have to try a couple of times and you do have to look for square numbers, it's a little bit easier to work with. So again, we have root 36 times the square root of 2. Because remember, each of these numbers are still under a root. Now we can take the square root of 36. Actually, the 5 would still be here. So that'd be 5 times 6 times square root of 2. So now I just got to put these 2 numbers together. 5 times 6 is 30. And that would be 30 over 2. Okay, so looks like we're done with that one. I don't see anything else we can do with it. Let's go ahead and move over to this one. Now again, with 45, you do have to think of large square numbers. You could also make a factor list like we did in the previous lesson. So if you remember the last lesson we worked on, we made a factor list. In fact, actually that might be an easier way. So we start off with 45 and then we think of numbers like 1 times 45, 3 times 15, and well, in this case it would be 5 times 9. And we look for the one that has the largest square number. So these are all of the factors that we can think of because you can't divide 45 by 6, 7, or 8, or any of these other numbers between here. So we don't have a whole lot of factors to go with. So 45 is not a square number, 15 is not a square number, so that's going to leave us with only 5 and 9. Now this 9 out front is going to stay there, so 9 times the square root. And let's pick our root number to go next, because we can take the square root of 9, and we cannot take the square root of 5, so we're going to put the 9 first before the 5. There we go. Now let's take the square root of 9, so we get 9 times 3. And I'm going to take that dot out. I haven't mentioned it, but yeah, I'm just going to leave that dot out because this is usually the way it's written anyway. So take the square root of 9, we have 3, so 9 times 3 is 27. And the root 5 just sort of stays there. There we go, and it looks like we're done. I don't see anything else we could do. You could also check your work by multiplying. So if you have a really good calculator, you could punch in 9 times the square root of 45, and it might give you a decimal number. Let me see if I can get it on my calculator. And I get something, well, okay, I must have pushed the wrong button, but you'll get a decimal number and then punch this into a calculator as well. And you should also get that same decimal number. Anyway, let's go ahead and move on to this one here. So 250. Now that would have a huge number of factors because it's divisible by a lot of numbers. But sometimes you can almost just sort of see a simple one. So like if one thing we could do is just start making numbers 25 times 10, which in this case, 25 is indeed a square number. And think of the factors that make your second number. So in this case, we have 10, which is 2 and 5. I only have 1, 2, and 1, 5. Those are the only two factors that can make 10. So we cannot break this down anymore, which means 25 is the largest factor we can take out. So in this case, we kind of lucked out, but with really big numbers, you might have to do a little bit of work. In fact, actually, I'm looking at the next number and it looks like we are going to have to do a little bit of work for number 12. So let's go ahead and get square root of 25 times square root of 10. Square root of 25 is 5. And again, with root 10, we can't do anything, cannot be broken down into any other number. So we're just gonna have to go ahead and leave it like that. And then now for 578 and for 578, we're gonna have to think of some numbers that would be, that would fit as a square number. So that's where you would look at your list of square numbers and we would try to get something to fit out of there. So I'm hoping this won't take too long. And I'm going to skip the 1 factor. Normally, whenever I make a factor tree, we use 1 because we're trying to make a complete list of factors. But in this case, we know that 578 is not a square number. So I'm going to skip that one. And I don't usually do that, so don't get in the habit of it. We're just going to have to do it for this time. So 578 divided by 2, and we get 289. Wait. 578 divided by 2, and we get 289. Okay, let's see, I forget on that list. Oh, okay, it's right there, 289. All right, so this is 20, 19, 18, 17. So it looks like that's gonna be the square root of 17. Oh, okay, well, I thought it would take a lot longer, but I guess we lucked out and it's actually not going to be that long. So we have to start with our original number on the outside times square root of 289 times square root of 2, because remember, these numbers are under a square root. All right, so let's go ahead and take the square root of 289, which we found out was 17. So we put 17 right there. 3 times 17, and I get 51. Times root 2, because the leftover stays in there underneath the radical. All right, so let's see what we got going on for the next thing here. And I'm not sure. I think radicals were covered in algebra 1. I don't know. I haven't taught algebra 1 in like 2 years, and I'm already forgetting. But I think it is somewhat covered, and I think it's like covered in 7th and 8th grade as well. So hopefully this is not all too new for everybody, and it's just kind of a review for you. So what do we need to know about solving? So we got to use square roots to solve quadratic equations. So what was a quadratic equation? So in this case here, we're looking for not the standard form. Because standard form, if you remember, was ax squared plus bx plus c. So in this case here, we're looking for equations that don't have a b value. So their b value is missing, or it just never was there. Now, if this happens, you can use the square root to solve. So if x squared is equal to a number, then x is equal to the positive and the negative square root of that number. And I know sometimes these sound confusing when you first hear them. You're like, well, what does that mean? But again, as always, hopefully once we get started, it'll be like, oh, okay, now I know. And this, once you know how it works, the rule is there to help you remember it. So let's go ahead and look at the steps. So we have isolate the x square. So that's one thing we got to do is get that x squared by itself. And then we take the square root of both sides. And this is what's different than most other equations. So anytime you're working with an equation, this is something you don't usually have. But anytime you take the square root of both sides, you need to put in a plus and minus symbol. So this means that it's the both positive and negative possibility of that answer. So just like with any other of the quadratic stuff we've covered, if it has an x square, then there are two possible solutions. Now, this doesn't mean there's always going to be two solutions, because remember, there's a couple of things that can happen, and I'm going to review them really quick. So if you have a parabola, two solutions is the most common because you have two contacts with the x-intercept. You could also have one contact. That would be one solution, and that would basically mean that both of them come out to be the same number. Or you could have no contact and there would be no solution. But in this case, I don't think there are any no solutions. Or in this case, it would not be no solution. It would be, well, sometimes you can call it no solution, but sometimes they also call it complex solution or imaginary solutions, depending on what kind of process you're working on getting the answers with. Again, I don't know when the vocabulary is kind of weird and it's hard to explain, and I just don't know how to explain it well enough. So I'm going to go ahead and just leave it at that. So anyway, let's go ahead and work on solving some of these. So it looks like we have a little bit more space to work on these so that we can use square roots to solve our quadratic equation. So now we have a quadratic. And again, there has to be no x value, because if there's an x value, then you can't really use this method of squaring, taking the square root of both sides to solve it. All right, so I'm going to go ahead and get that x squared by itself. So that was the first step. We got to isolate this x squared. And I'm going to do that by adding 64 to both sides. So add 64 and we get, well, positive 64 on this side equals x squared. From here, remember when you solve for a variable, so in this case we're solving for x, you always do the opposite of what's happening to that x. So opposite of what's happening to this x is that it's being squared. So the opposite is we have to take the square root. So the square and the square root will undo each other. They are inverse operations. Now you might be saying, okay, well, it'd just be 8 and we're good. But there was that third step that we might have missed, and that was we have to consider the positive and negative possibility. So in this case here, we could leave it like this, and I think this is the way most worksheets will have you do it. You could also do it the old way we did it and use set builder notation. Because in this case, this set contains -8 and +8, like that. So it might be easier to see. But again, just for this purpose of this exercise, I want people also to get used to the plus and minus symbol. So again, there are two solutions. It's just they're both the same number, just different directions, right? So we have a positive and a -8. All right, so not too bad. Let's go ahead and work on the next one. So for this one here, we have to isolate that x squared again. So let's get rid of this 8 by minusing 8 from both sides. 15 minus 8 would be 7. All right, but we still got to work on this, and you're still going to use your same order of operations, meaning the, well, not really the order of operations, but the order in which we do things to solve. And I have a poster in my classroom. Well, hopefully you remember it. So remember, it's like work with the parentheses and like terms, pick a side for the variable, do the add and subtract, multiply or divide. But now we have a new operation that goes in there, and this is usually not something that's common, and that's usually why it's not on there. So if you look at that list in my classroom, it doesn't have it because it's just not that common. And that really last thing in this case, the last thing we should do is take the root of both sides. So take the square root here, take the square root there. So square root of x squared, so that'd be just x. And 1 is a square number. So if we take the square root of 1, now you might be asking yourself, why do we have to have the negative and the positive? Well, okay, so remember what this means. This means a number squared, so x squared. What number can I square to get 1? Well, okay, well 1 times 1 equals 1. That's what most people would say. But there's another possibility as well, and that is negative 1 times negative 1 is also positive 1. Just like here, what number, if I square it, can give me 64? Well, most people would say 8, but you could also say negative 8 times negative 8 is still 64. So that's why both positive and negative 1 in this case are solutions. Because again, you can square a negative number and still get a positive value. All right, let's go ahead and do this one here. So minus 5. So 81x squared equals, and then I'm going to have 21 minus 5. This would be 16. And then now I have to get rid of that 81. So I got to do the addition and subtraction. So this would be 81. So x squared equals 16 over 81. So if I take the, it looks like I'm going to have to take the root of both sides. So that means the root of 16 and 81. Now, I'm going to kind of skip a step because as you can see, I'm kind of already running out of space. I'm going to go ahead and just write the square root of top and bottom number instead of just, making a big one over both of them. So hopefully this should help us out. Oh, there's no more square. We got rid of that square. That's the whole reason we took the square root of here. So that is gone. And then I would have 4 over 9 because square root of 16 is 4 and square root of 81 is 9. But again, let's include the positive and the negative number. In this case, I made that negative a little too close. I don't like having my numbers line up because if you looked at it the way it was before, it would be kind of hard to tell that it's all one line, and they were so close together that if I wasn't paying attention, I might mark that as wrong because I might not see that there was a minus symbol in there as well. So I usually don't like to mix up my minuses, my equals, and my fraction bars. So I kind of put them a little bit spaced out just so they're not so, again, they don't get so close that they get confused with each other. Anyway, let's go ahead and move on to the next one, which how many more do I have? Oh, like I said, it's not a very long lesson because it looks like we only have 2 more to go. All right, so let's go ahead and get these done. So it's about 6 more problems, exercises. Problems make it sound like something's bad, which these are not bad. All right, so 17 minus 1 is 16, and it looks like I'm gonna have to get rid of this 8 here. So I'm gonna work to get rid of that 8, and in this case, I can divide this fraction. 16 does divide nicely by 8, which gives us 2. Now, again, what number, if I square it, gives me 2? Well, there is no number that I could square to get 2. And usually during a normal school year, I'll usually play with a calculator just to kind of get students to think about what square root of 2 means. So again, what 2 numbers can I multiply to get 2? So I'm going to go ahead and move over to the calculator. And strangely enough, if I ask students, what are 2 numbers that can multiply to 2? One of the first answers I'll get is 1 times 1. Because it's not 1 plus 1, it's 1 times 1, and they get that confused, so that's not it. And then the other one I get is 1.5. Well, what is 1.5 times 1.5? Now in this case, we get a number higher than 2. We get a number that is higher than 2. We get 2.25, but we're trying to get as close as we can to 2. So they might say, well, let's try 1.4. So let's try 1.4 times 1.4, and you get even closer to 2, because 1.96, that's really, really close. You know, if this was like, if we were trying to get $2, we'd only be four pennies off. So what else could we try? So we could try 1.4, and remember, we need to go a little bit higher, 1.41 maybe, times 1.41. And we're getting even closer. And in this case, I think if I were to go to 1.42, and I'm going to square it, we go over. So it's not, it's going to have to be 1.41 something. So we're going to need an extra number. So let's try 5. And then square this. And we get so close. I mean, this is like if this was dollar amounts, there would, you know, it would be so close that not even pennies could get that close. So we know we're getting closer, 1.41, what did I say? Okay, well, let's square this, and we're getting even closer, but you get the idea. Now, if I was going to just skip this whole thing and go with the calculator, so in this case, I got 1.412. So if I just type in square root of 2, where's that square root? Oh, here it is. 1.41421, and we get all these numbers. Now, if I were to multiply all these numbers, I would get something like 1.999999, because this number goes on and on forever, and I can't type in numbers that go on and on forever. So a number, like again, really close to 1.414 would be really, really close. But that's why, and that's why the reason I showed you this is because we're going to do something a little bit different. Rather than say 1.4142 or whatever, let's just leave it in the radical. All right, I'm just going to leave it in the radical. I don't want the decimal, because it's just easier to write one number in a radical than it would be to try to write all those decimals out. And plus that too, you can do it this way without a calculator. So if you don't have a calculator, so which again, you don't have to do what I did. I just did that to show you what a square means, what a square root number means. And sometimes when I show that to students, they're like, oh, okay, now it makes sense. Now I know what a square is. All right, so let's go and move on to this next one. I spent a little bit of extra time on that first one. So I'm gonna kind of go through this one a little bit quicker unless I see something that is out of the ordinary. So in this case, I have 64. Now, if we were to take the square root of both sides here, oh, we can't because, well, we still have a 2 there. But it would have been a nice square number here. But in this case here, it looks like we're going to have to take this, we're going to have to take the square root of 32, which is not a square number. Well, we're going to have to stick with our rules. Remember, we got to look for that largest square number. So I'm going to take the square root of both sides, and that should give us our x value. Now for 32, right, we want 32, and we're going to break that. And remember, this is a root number, so it'd be root times 16 times root 2. And I kind of already knew this one because, well, it's small enough to where you could easily kind of look at it and say, okay, well, 16 times 2. And then you're like, oh, okay, so 16 is already a square number, so let's go with 16. And in this case here, don't forget the plus and the minus. We take the square root of 16, which is 4, and then we have our leftover that stays in the radical. So again, it's not, in a way you can think of it like it's not powerful enough to come out like a baby kangaroo. It's just not powerful enough to leave its pouch yet. Or like an egg, I guess, too. Anyway, and there's nothing else we can do with this one, so I'm going to go ahead and call that one done. And let's go ahead and start working on the next one. So again, use your ordinary rules for doing any kind of solving. So anytime you have solving to do, just do the same thing. So minus, do your addition, subtraction in this case first. And then we have to do our multiplication and division, which in this case, I'm going to have to divide both sides by 9. And I get x squared, and I don't know what 108 divided by 9 is, or if it can be divided, which in this case, it looks like we get 12. So I'm going to take the square root of both of these. And I know that taking the square off of an x is going to just leave it as x because they're inverse operations. Square and square root are opposites or inverse operations. Now I need 12, and I'm going to break it down into two different numbers. But again, remember, this is root 12, and I already know what this is because you might say, well, 2 and 6, but neither of those are square numbers. But we're going to need 4 and 3. And we can take the square root of 4. So I'm going to take the square root of 4, which is 2. And we cannot take the square root of 3, so it's going to stay as a leftover. Don't forget your plus and minus, which in this case I almost did. And I'm gonna rewrite this just so I have a little bit more space in there. Plus and minus 4 times, sorry, square root of 4, which is 2, and then root 3. So far, I don't think any of these would have been really difficult. I think that we would have gotten most of these. But let's hope I don't jinx it. Well, I'm just saying that, you know, you should be able to kind of get these, even though normally there'd be like a kind of a lead up to this lesson. I feel like everyone would be kind of at that point where they'd be able to get it. Anyway, let's go ahead and move on to the last slide. All right, let's see what we have going on here. Okay, so let's take care of our addition and subtraction first. I'm going to subtract both sides. And in this case, I have 77. Well, they're both negative, so it's going to stack up to a bigger negative. And I'm pretty sure that's going to be 81. Oh, let me not forget the signs, because I knew I was adding them, but in this case, if you add two negatives, they become a bigger negative. Anyways, let's go ahead and take care of our division, which in this case, I have to divide both sides by -3. Because I got to get rid of the 3, but I also have to get rid of that negative as well. So 81 divided by 3, and this would be 27. Because the negative divided by negative is positive. Make sure I got the right number. It looks like I don't see anything wrong with it, so it looks like, yeah, we're on the right track. So take the square root of both sides. Now 27 is actually a cube root, but we're gonna have to break it down. So 27 into squares. So I need a square number. So in this case, I would have 3 and 9, but I'm actually gonna reverse the order because I want this number to go first. So I'm gonna have 9 and then 3, because when I write it, x, because again, we take it out of this square, takes it out of the square root. And then we have no numbers on the outside, so I'm gonna go ahead and just take the root of this number. So we have 3 times the square root of 3. And don't forget that plus and minus. In fact, you know what? Maybe I should just start writing that first. As soon as I write that x equals, I'm going to put that plus and minus symbol in there. But again, you do need it, and I'm trying to draw your attention to it because, you know, I will get students that will not have it in there, and that would only give me one solution out of 2 solutions. So missing a solution is not good. All right, so let's go ahead and start with this one here. Looks like we're off to an easy start, because 310 minus 10 would just be 300. And then looks like I just have to get rid of this 5, so divide both sides by 5. X squared equals 300 divided by 5. Punch that on my calculator and I get 60. Now, x squared, what number can I square to get 60? Well, it's not really a number that I can think of, so we're going to have to simplify this using simplifying radicals. So x squared, if we take the square root of that, just becomes x. And now I need 60. So again, what 2 numbers can I multiply to get 60? So there's 2 and 30, but neither of those are square numbers. There's 3 and 20, but neither of those are square numbers. Okay, I said 3 and 20, so 4. Let's try 4 and 15. Now 15, so we know 4 is a square number, but let's look at 15 and see if there are any more square numbers. 15 is made from 3 and 5, so there's no match. There's no other numbers that we can use. So in this case, it's got to stay 4 and 15. So sometimes you might need to break a number down to see if you can take an even bigger number out of it. So in this case here, I'm going to put, well, actually I already have the square number first. So square of 4 is 2 and 15. And I just said I was going to put the plus and the minus in there. Whew. Like I said, I'm having an off day. I don't know what's going on. I just kind of got this. Actually, I kind of woke up with a weird headache this morning. And that would normally worry me, but they check us whenever we go into the building. So like this morning, I got my temperature taken, and there's nothing out of the ordinary, I think. But if I was sick, I'm pretty sure they would have caught that by now. All right, so here I am going to multiply. Now, here I have times by half. And if you remember, timesing something by half is the same as dividing it by 2. So if I ask a student, okay, well, how do I get rid of this 1/2? Well, they might say multiply it by 2/1. And that's true. Now, 2/1 is the same thing as just 2, because any number divided by 1 is going to be that same number. So on this side, I'm just going to say times by -2. Or you could even turn it into a decimal, like 0.5, and then how would you get rid of that, right? So you divide both sides by 0.5, and a calculator would tell you that without really thinking about it. But I'm also, again, just showing you that a fraction is kind of like a division. I'm just reminding you. Anyway, if we multiply this, 2 times 1 is 2. 1 times 2, our bottom numbers, is also 2. Negative times negative is positive, so we end up with 2/2, or 2 divided by 2, which is just going to be 1. And 1 times x squared is just going to be x squared. So that cancels that whole thing out. -4 times -2, so that's going to be a positive 8 in this case. Oh, you know what? That's supposed to be 40, not 4. I don't know why I missed that, because I just looked at it just now and I was like, oh, it's a 40, not 4. Not really a math error, but it still would have thrown everything off anyway. Anyway, let's go ahead and take the square root of both sides. And that would give us the square root of root 80, but we need to simplify this down. So 80, and again, we can do a couple of things. I can break this down into 2 numbers, right? We can break it down into 2 and 40, but neither of those are square numbers. So let's start off with a square number. Let's do that. 4 and 20. Now, if we look at 20, are there any more square numbers inside of 20? Yeah, there is, 4 and 5. Because 4 times 5 makes 20. That means that I have 2 square numbers. Now, this would be pretty easy because it would just be 4 squared and I could take out the 4. But one thing that might also help is to rewrite this in a way that makes another possibility. So we have 16 times 5, and that's a much easier way of getting this number. And I know maybe I'm probably confusing people by showing them all these different ways, but you know, we already know that 4 squared, and we take the root of it, we just get 4. But we can also take the square root of 16 and the square root of 5, which if we take the square root of 16, we get 4 and 5. And wouldn't you know, I did it like another time. Gosh. I kind of had a headache yesterday too, but I don't know what it could be though. All right, so x is equal to the positive and negative of 4 root 5. And I'm pretty sure there's nothing after this. And again, that was kind of a shorter lesson. I don't know how long that was. I think it's a little bit less than an hour, but we got started a bit late. So at least for us, that's pretty good. Now, there's also a little bit of an error in the packet as well. The last 2 lessons we did, factoring refresher and solve by factoring, in the book, they are kind of the same lesson. So when I was covering them, I ended up splitting them into 2 separate lessons. So that was the whole Loif method, and you know, start with your last number, then work with those 2 numbers that'll add up to your middle number, and so on, all right? But I thought it would have been a lot better if I split those into 2 separate lessons. And unfortunately, that had the side effect of one of the packet lessons is going to repeat itself. So that's, if you look at week 15 packet, which is not out yet, it starts off with one of the lessons that are already going to be covered. So don't worry about that. Just follow what you get in the lessons. You know, if you're watching the videos, just go with whatever's in the video, okay? But again, that one had two, it had an extra lesson in it, so it might be a little bit confusing, but we'll be back on track. But trust me, it was better this way. It was kind of one of those things I made a decision of at the last minute because I almost debated skipping a lesson, but I know factoring is very important and one of those things that is easy to forget, especially with all the stuff going on. So be careful with that in the packet. Anyway, that's going to be it for today. I'll go ahead and wind off this lesson. So if you have any questions, let me know. If not, then I will see you next time. Bye-bye.